So just out of curiosity, has anyone ever seen me speak before? A few people? So it's usually mostly just like disconnected gibberish. But today's going to be extra special, even more gibberish. So this is a little talk, and as Marco said, and I've had many conversations about this with other people and with myself. There's kind of this movement in the industry to try to get things better. I think it's a competitive advantage to be more operable, and there's actually some references and some data to support that as well. But then, and I'll make this point pretty strong by the end, hopefully. There's also been maybe less, or when you start thinking about, he said dev and ops and like connecting two sides, it's not, people aren't always thinking so much, at least in my conversations, about what they're automating. Like there's been more, and maybe that's a sampling bias from my side, there's been more emphasis on trying to build better automation and less thought put into like the architecture that you're actually automating, right? And I think that's a tension that is, apparently putting everything in Docker will not solve that for you, despite what you might have heard. All right, so sometimes I give an introduction and I say like I did a bunch of stuff, but Google, I don't know. Like I don't want to tell that story anymore. Right now I happen to work for Pivotal, which affords me the chance to like fly from Los Angeles to London and like, I don't know, maybe eat sushi later with whoever wants to go. But we're also hiring people. And it's, I'll give it a very, very, like the strongest recommendation I make is it's not the worst place to work. So if wherever you're at is, that other thing. And then this is something my lawyer made me put in. I'll let you read that. Tell me when you're done. It's probably fine. Okay. In a perfect world, every service would be state machines emitting events on networked fabric of self-determined list machines. If you know what all that means, then we should probably hang out. If you think that's true, then we should probably be friends. Whoever worked on a list machine? Anyone? No? Yes? All right, never mind. We don't live in that world. What world do we live in? Who's ever read this essay? That worse is better. What's the basic argument? Anyone? So this is an essay that basically argues that, and it explicitly calls out the MIT method and what he calls the New Jersey method, which the MIT method is sort of epitomized by list machines. And these types of, idealized approaches to computing, lambda calculus, whatever. And the argument is basically that like these kind of cobbled together solutions that get to kind of a working state faster have properties that are superior in some other context that doesn't actually make sense to me, but here we are. Because like, honestly, this is like the principle of like most of what we do every day in this industry. Who disagrees with this? What's that? It can. No, broken goes away rather fast, actually. If something's totally broken, usually it'll go away. Right? Shitty turns into broken sometimes. And like our tolerance for what is the line between shitty and broken is different. I think there's especially in the ops side of things, there's been a propensity for a high pain tolerance that kind of drives a bunch of bad behaviors on like every side of that equation. Because you set up these cycles of heroism, and then you're yeah, anyway. Well, that's not this talk. There's lots of other talks about that stuff. So this is actually a practical question. And one of the things I wanted to talk about a little bit is like this notion of like usability. Like in order for something to be operable, it kind of has to be usable, right? And there's like this tension in usability, and a lot of times we don't get to talk too much about usability in operations work, but every time you interact with a CLI or an API or any of these things, like there's a usability aspect to that, right? And there's also, whoever used LXC, like whoever built anything sophisticated with LXC. Like LXC is pretty cool, right? But the problem with LXC is it's too powerful, right? Like and it forces you to make like every knob. It forces you to do like a lot more than something like Docker does, right? Where Docker just kind of gives you like this sensible like defaults, knock on wood, and then like hopefully it works. This is actually my hotel room. I took this picture this morning. Because I can't figure out how to turn the heat down. Because I pushed the button and turned it all the way up, and now it's only one button. And I don't know how to turn it down. So is that, why does it turn off? Because I don't turn it fast enough?
I think you keep pressing that button.
Which button?
The cool and warm button. We're at the same hotel. You just keep pressing that button. And
I pushed it a lot, Bridget. Maybe it is. What's that?
Does it respond to a long press? I've seen a single button design before, which is horrible.
I don't know. I'm just putting it out there. Like it. I mean, maybe there's like a Steve Jobs thing. They're like one button. That's it. We're not giving you two. But I could not figure out how to turn it down. Yeah. So this is kind of the double edge, like this thing of who's ever said this or who believes this, like working code first. Like I got in a little bit of an argument with actually someone who's my friend on Twitter the other day, because they were upset at another person that I know, because that person wrote what I thought was a relatively thoughtful essay about getting rid of the abstractions in operating systems, which I think is a coming wave, which we're not going to talk about that too much today, but it's basically like everyone's excited about containers, and containers are kind of like this intermediate step, because at the point where like all you really want to have is like this little service that just does like some HTTP thing, like why do you need a multi-purpose operating system? Like just get to unikernels already and like get rid of all this garbage that we deal with. But that requires like revisiting certain assumptions about how things work, and so what we tend to do, this is the shitty list forever, like we have all these layers of this stack, right? And when someone says full stack, like I kind of want to laugh at them, because like there's no one alive right now that really understands how deep and how wide the stack is, right? Like when someone says full stack, usually they mean from, like the JavaScript in the DOM to like the JavaScript in Node.js. And I'm like, if you're gonna say full stack, like, I don't know, at least talk about the kernel or something, I don't know. But that working code first got us to this point where like there's all these assumptions that start at the kernel that you kind of build up. Like if you really wanted to solve some of these problems fundamentally, you'd implement something that looks like configuration management in the kernel, right? Like you'd implement distributed systems primitives at that level. Like you'd implement certain aspects, and I think that will maybe emerge. Depends on how fast like someone gets to the point where they're convinced that what the shitty is like overwhelming enough to do that work. I think there's some interesting projects like, does anyone know what OSV is? Yes? OSV or Open Mirage or like some of these other projects that are kind of interesting. Anyway, maybe someone will, those are like hard problems to solve, and it takes like actually thinking about the problem. So in deference to someone who thought about problems before, this is a quote from Albert Einstein, who you might have heard of before. He did a few things. And he said, if I had an hour to solve a problem, I'd spend 55 minutes thinking about the problem and 5 minutes thinking about the solutions. How many people in your work like think it's like this way? Zero? And I think it's interesting to watch and reflect on my own career too. It's like we don't reward deep thinking in our work, in our industry. For the most part, we reward like the first mover, not the best mover. All right, so let's define the problem. How about that? Why not? So here's a little thing I'm going to say. Words, they mean stuff. So I started trying to figure out what is operable. What does operable mean? And so I started with the dictionary, obviously. And operable comes right out of the gate with like the word operation. Capable of being put into use, operation, or practice. Okay. Doesn't really answer every question I have yet, but it's a start. So then I got to operational. And it's like, wait a minute, you're defining it again with operation? Like, I don't understand. You haven't given me anything yet. Fit for proper use, ready for use, blah, blah, blah. And then I looked up operation, and it's like, for fuck's sake. Like, you just keep going in circles here. Like, you're not telling me anything. But then this is my favorite one, the next one. Yeah. And we'll just rush through those. So this is actually another interesting one. I pulled the ones I think are kind of pertinent. We're not going to cut anyone open today. And actually, when we say operation of a computer, like the register, that's different than what we're talking about. I do like mathematics, but we're going to skip that today. So I'm going to kind of pull that out, and that's a lesson that you should not consult dictionaries if you want to know what words mean. Because we're kind of defining them. Why are you doing this, projector? So these are ones I think are kind of interesting for what we're talking about. So the state or process of operating or functioning, the state of being operative or functional, a process or series of acts involved in a particular form of work. Like that, I think that sometimes we get a little process heavy, but it's definitely nice to have checklists and like mental things to go through. An instance or method of efficient productive activity. Productive activity. And then this is another thing that, it's also interesting when you start talking to business people who, when they say they work in operations, they mean a very different thing than when someone is in IT operations. Has anyone ever had that conversation where you're like totally talking past each other and you think you're like having a conversation, but you're not? It's amazing. But I would encourage, this is an aside, if you've ever seen me talk before, like there's plenty of asides, editorialization. It behooves every single person, no matter what you do, to figure out how you should think about business and what it means to like add to the value of a business. Not just so you can do it for wherever you work now, but so you can control your destiny, basically. Because you're going to be more rewarded for that than you are for like figuring out like niggling bits of how the computers work. Guaranteed. Like the other bit that I'll just editorialize, 2 things will make your career more valuable than anything else you can learn with computers. Learn how to speak and learn how to write. Learn how to communicate. That will give you more leverage in your career than anything else. That's my advice to you as operations or like developers. All right, more searches of the internet got me to this, straight off Wikipedia. Operability is the ability to keep a system in a safe and reliable functioning condition according to predefined operational requirements. Okay. But what about skill? Like, can everyone operate the same thing? Right? Like, there's an aspect of skill involved in at least my experience as a. I'm not going to say I'm a professional in anything, but I got paid to do some stuff before. What about ease? Like, how easy is it to do something? Is that a function of operability? What about joy? Who has a good time at work? This guy looks like he never has a good time. By whom? For what purpose? All right, so many questions. So many questions. And that was just a really pretty picture. And I was like, it's so abstract. I'm just going to stare at it for a while. And then I thought, well, maybe I should try to bring it back into something that's connected to this conference. So what's a context that makes sense? And then I also wanted to recognize that in context, that what seems like an optimal solution in one context is not optimal in another context. Who's ever, so who knows what these are? Who's ever seen a good American demolition derby? Do they do those in Europe? Doesn't seem like a European thing to do. But they have Formula One, right? So Formula One cars, I've had some interesting conversations with people that build and race those, where they basically said the perfect car wins the race, crosses the finish line first, and then falls apart. Right? Like that's the perfect car. Like it's so like you don't want any more investment than it takes to win, and then just like you're done. Might as well throw it away. And then for those of you who are not Americans, demolition derby is basically like they go and they get a big thing of mud basically with a bunch of people who have nothing better to do, and then they drive cars around and they crash into each other. I don't even know how you win. How do you win? Does anyone know? Like if the last car that will move basically. Yeah, so it's a great way to spend the evening with your family. But what I will tell you is, and I say this with certainty, I didn't actually do the science, that if you take a Formula One car and put it in the demolition derby, I don't think it will actually do very well. I'm going to assert that. I'm pretty comfortable making that assertion. And then conversely, I don't think that these cars on the right would do very well trying to do laps. Not at all. So context, context, context. Most important thing. So the context for today is to come and learn from your peers how new processes, tools, and techniques are changing IT operations forever. You can tell I'm very skilled at searching the internet because I got this off Marco's website for this conference. Right? You wrote this. Yeah. So what even is IT operations? So again, I went right back to Google. And this is what I found. Information technology operations, or IT operations, are the set of all processes and services that are both provisioned by an IT staff to their external or external clients and used by themselves to run themselves as a business. And I basically just came to London to read you guys' Wikipedia. To run themselves as a business. So now we got like a little bit of purpose and a little bit of context. And I think that phraseology, we'll call it phraseology, is actually sort of dated. In the context that we live in or that I live in, it's not necessarily about IT as this sort of thing that is external. Like IT is everything. Right? The software dynamic, the disruption that's happening in the world where I live, and maybe you live there, maybe you don't, like software is going to transform everything that it can. Right? Like you're seeing this in real time if you're really paying attention. Like who's ever used Uber? I took it like 3 times yesterday. And I was reading an article about San Francisco. They said that the taxi fares in San Francisco have dropped 60% in 1 year. So if you're a business, and in many cases, like that's a fairly entrenched business. Taxi was like a thing, right? For decades. And all of a sudden you saw a 60% drop in your revenue in 1 year, what would you be thinking? Seriously. And you're seeing this type of disruption. I think that you can make a pretty strong argument that every aspect of human performance and human experience that can be improved or affected in whatever dynamic by connecting us to essentially supercomputers. Like this thing I carry around in my pocket is like, it's a supercomputer, by the standards of when I was in school. And it's connected to pretty much everything that all of humanity knows on a high-speed network 99% of the time. unless I go to San Francisco. Seriously. All right, so here's the real talk. Who's ever seen this picture? I put this picture in a lot of my decks before. And this is actually, it's interesting to watch all this evolve because Marco just said, oh, it's finally getting interesting to have these talks about operations. This is a picture from O'Reilly Radar in 2007. Right, so almost a decade since this was published. And the original argument, and this is in the US terms, about, 6 years after the first bubble, right before the financial crisis. So everyone's kind of getting excited about startups. And then like all the funding goes away for a second, and then you see this explosion over the last maybe 5, 6 years where it's just ridiculous. Who does any startup stuff? And I know London's having a bit of this too, but the funding in San Francisco, crazy. There's not a bubble. Knock on wood. So the operations is a secret sauce argument is essentially that, and I don't think these are to scale, and I thought about this over and over, and I've had 8 years to do it. I don't think this is necessarily to scale, especially at the time, and probably not accounting for equal levels of skill. Right? If you start with the same levels of skill, but I think that there's a couple things to think about here. One is that you're making this investment. I think this should probably actually be bigger. Like this part of the graph should probably be bigger if you're starting with equal teams. But what this really represents to me in some sense is thinking more about the problem, right? Going more the Einstein route and saying like we're gonna pre-solve our scaling problem by designing our system, our configuration, our architecture in such a way that as we scale up the number of servers, that we don't have this ridiculous scaling cost to do so. Has anyone ever lived this graph? Either side of it? I know Colin has. Does this resonate with your mindset? Like this is 2007 though, right? So what did it take for this to kind of permeate and get to a place where we're at today? It's kind of interesting because it's like I keep having the same conversation over and over since 2007, 2008. And it always seems like, for the most part, everyone in the room is new, right? So either I'm not doing a very good job or more people need to start talking. Like why is this not the thing that everyone's thinking? Why is the industry not realizing that operations is a huge competitive advantage? I believe it is. I think if you look at the best kind of startups, their advantage, the advantage of Amazon, I don't have a lot of Amazon references in this deck today, but the advantage Amazon has over everyone else is operations. They have a massive head start operating a completely ridiculous planetary scale web infrastructure, and they did that for 15 years before you saw EC2. And so you see all these sort of enterprise people trying to provide clouds. They don't have a web operations background, and they fall over themselves trying to just get the basic idea that you have to manage this distributed system. Arguably, I think Google has advantages on that sort of management and tech side of the scale. They haven't. I think the guys at Google probably sit around and wonder like, our tech's so good. I wonder why no one uses it. And what's that? Well, yeah, it goes right back to usability, actually. And the fact that all technology is driven by tribalism and fashion, more than actual. Well, who's more credible on cloud than Google?
Some people going on gut. I think it has nothing to do with.
I think in my experience that most of the decisions get made based on inertia and tribal affiliation and not actual analysis of the technology. And so once you have an ecosystem around a tool, like that's what people do, and they show their friends, and then that spreads, and it acts as a barrier to superior solutions. So what I think this last thing, the difference between this slope and this thing over here is really interest on technical debt. Right? So the operational cost of these two approaches, and obviously like that's sort of a spectrum maybe, and there's everything in between, and there's probably worse and there's probably better. But that difference, that delta between the two slopes is what I'm going to consider technical debt. And that has to do with how you do the configuration, that has to do with how you do the architecture, all these things. Operability. I think it's interest on automation debt, an interest on architecture debt, and also an interest on process debt, human debt. And across the industry, and I had a front row seat because of mostly luck and circumstance, but I got to watch lots of people build lots of things, and everyone did this over and over and over. Like the same mistake. And I did these mistakes as well, and I'm going to tell you a little bit about that. So this is something that I used to say in DEX since really 2007, 2008. You can either manage complex systems at scale, and if I said this today, I'd probably take complex out. We'll get to that by the end. But this is like straight from DEX I used to give. You can either do this, or you can't. Who can do this right now? For small values of scale, right? So I've been using that same slide for a ton of time. Like I've been using that over and over, and I think it's still true, but the game is definitely changing, right? The tools that we have available now are very different than what we had in 2007. Thankfully. Some of them are better. Some of them are like just sideways, but that's cool. So who knows what all these words mean? I don't actually know what they mean. Yeah, it's for the bingo game. But I think it's really hard to have a conversation when someone, especially when they're trying to make executive level decisions for their company, are like, we need to have a DevOps initiative, and then as a separate thing, we're going to talk about continuous delivery, right? And then microservices is like our next initiative after that. You're like, really? You're not watching this movie. You don't understand the plot at all. And what I'm going to say, I'm going to keep saying it over and over. I didn't put this in the slides today, but I think this kind of new thing, this new emergent architecture, this new emergent process and practice, I'm going to call it cloud native, because why not? It gives me like a big umbrella to like put all this stuff together and put it in one thing. So everything that's new and awesome, I'm going to call cloud native. Everything that's old and broken, like something else. I don't know. You could call it whatever you want. But these are definitely patterns that emerged in these organizations that deliver highly available applications continuously at scale. Like it's a very common, and you can go, to Twitter, to Facebook, to Netflix, to Amazon, to Google, to whatever, and they're not identical, but they're very similar. And you can see like common patterns about both the way that they approach automation, the way that they approach architecture, the way that they approach monitoring, the way they approach alerting, the way they approach all these other things. They're very, very similar. So what happened to change everything? And what actually changed? So I'm going to rewind a little bit, and I'm going to tell a story about, this is kind of my story. So this is me. I learned some automation. I was like, I got this tool. I'm gonna build stuff. I'm gonna automate it. I can automate anything. And so then I was like, I'm gonna have these brooms carry water. And it's pretty exciting. I was very proud of it. I can automate anything. And then I kept doing that. And then next thing I knew, I was like, what's the matter? That was not the way this story was supposed to go. It seemed so right at the time. And I think the problem is, or one of the problems at the time, is I was really very focused on the capabilities of the automation and the tooling, and not so not so cognizant of or focused on what I was actually automating. And I think I was actually better at this than a lot of people across the industry. Like I had a propensity to go back at least one level to why, but still I think there were a lot of fundamental assumptions. When you find, and this is the same at kind of any level of the architecture or the code, when you find something is there and you understand what it is, that's a certain level of understanding, but that is not as powerful as why it's there, right? And if you understand why something's there, that gives you a lot of power to do things. Like, what does this guy actually want to do in this picture? It's like, I think what he's trying to do here is use the napkin, right? So it's a relatively complicated solution to using the napkin. And I bet, with the brain power in this room, if we sat and thought about it for a little while, we could come up with better solutions for using a napkin, right? But what I did, and maybe some of you did before, is I was like, look at this. I'm going to automate it. And so pretty soon, like, I got a solution, and it pretty much works like it did. I mean, everything, I do the thing, the cracker goes, the bird gets it, like the thing, bottle rocket and the clock, working as designed. Problem solved. And I could do this over and over because I had the power of automation. So pretty soon I was like, let's get more of these. And you know where this is going, right? And then I was like, whoa, let's just get, like, come on. How about some more? Because I have this power. And I'm sure some of you have lived this. Or maybe you're about to. Who saw the Kelsey Hightower Tetris thing on YouTube or whatever the other day? You know what I'm talking about? Anyone?
Bits of it on Twitter.
What's that?
Bits of it on Twitter from Automacon.
Yeah, it's from Automacon. But he was playing Tetris and he was talking about, basically, he had like a few divergent topics about how bad Java is or whatever, but whatever. But he was making this argument about like how schedulers work, and you can like put automated stuff, and it'll do like the right placement, and this is bin packing, and that's cool. And then, have you ever played the old Nintendo levels of Tetris? You could start where there's already like some stuff, right? And so he started one level like that, and he's like, this is like the Enterprise, right? And so you start a pie, and you got all this stuff, and then you're like trying to do it, and then it's harder, and they move faster, or whatever. Okay, fine. I don't think Tetris is a perfect metaphor, but let's explore it a little bit. And I didn't make this up, but I think it's true. If Tetris has taught me anything, it's that errors pile up and accomplishments disappear. And I don't think there's a truer statement than this for operations. Like, that's pretty much how most operations works. But in the real game that most of us played, the blocks don't just sit still. It would be great if the blocks just fell and you could kind of count on them staying there, being well behaved. If only. I think most of us are playing a game that looks more like this. And then, the next thing you know, you're like, there's a new block, and it's like, what is going on? And then there's like these other things, and they're shooting at me. And then there's zombies and dragons. And then, like, I have more than one data center. It's terrible. Who's ever seen that movie? No one? I don't know, the data center movie that I just thought this was a really cool picture of a dragon. And I was just trying to figure out, like, what's going to happen to that guy. I don't know, maybe he's warm now. It looks lonely up there. Who's ever read any systems thinking, like management books or like the system thinking stuff from Sengi and that kind of stuff? It's all like 90s, and it's all kind of high-level abstract stuff. But one of the things that they talk about in that model is this notion of resistance, right? And that as human beings, we tend to like focus on a solution and then pushing that solution harder and harder. right? So like, let's add more thrust. And what systems thinking implies is that you can often get more return for the effort if you focus on removing resistance. So instead of pushing harder all the time, sometimes you should figure out, what's in front of whatever you're pushing, or what's the friction on the floor, or whatever these other factors are that are stopping the thing that you want to happen from happening, instead of pushing harder and harder for it to happen all the time. And that's a very, very abstract statement and way to frame that. But there's many examples in the types of technology that people have adopted that I think it makes a lot of sense to like back up and be like, hey, let's not run MongoDB. Because we like our data. Sorry. Anyway. So what if you were playing this game, but you only had the small blocks? Right? Or maybe instead of just, like, let's ignore the White Walkers and the dragons for a minute, and the OpenStacks. But let's say you just had blocks that were just only the big squares or the long straight ones. Like, that would be an easier game, right? And it turns out, if you're a developer, you're kind of choosing like what to drop in, right? So, like, how can you constrain, or how can you get to a cooperative model where people are only dropping in the blocks that make sense? And there's organizations that do this, right? Like, if you look at, and this isn't the way that I framed it in this talk, but if you look at what's going on at a place like Netflix, they do not have a system to do ad hoc automation, right? They optimize for self-service deployments for their developers. But what you are allowed to deploy is from this palette of kind of microservice components. And then you can put your domain, but it's basically Java. There's a little bit of Node. They have a very like structured way of thinking about it. It's not just, hey, here's this like random thing that I happen to put in Docker for you. Good luck. Have fun. And what if the little small blocks were actually telling you what they needed all the time? How many people are writing applications right now that are aware of their own health? Who knows what the Borg is? The Google paper. So this paper, if you've never read this, you should read it, just to think about it. It might be, depending on what you thought about before, it might seem like a lot of detail. But basically, this is something that Google considered their secret weapon for a long time. And they just barely published this paper recently. And the Borg, in some sense, is kind of like the spiritual inspiration for Mesos, for Cloud Foundry, and also Kubernetes. Like, it's a lot of like what I'll call like the Google diaspora of SREs or whatever that kind of worked with these systems that wanted these kind of capabilities that like are bleeding into the systems that we're building now. And if you go read this paper, it talks about the scheduling, it talks about the abstractions, it talks about long-running processes, and talks about all this stuff. But I think this is actually the most important sentence in the whole paper. And I think it's one little sentence that very few people like bring out. But I think this is actually, if you look at what they're doing, if you actually see what Google's capable of and why they're capable of it, Borg, if this was not true, would be at least 50% reduced in its efficiency, in my opinion. And if you internalize this idea in your own kind of architectures and approaches, like it will have a profound impact on how you think about the world. So every task running on Borg contains a built-in HTTP server that publishes information about the health of the task and thousands of performance metrics. How many people build this stuff like that right now? That's the key right there, in my opinion. It's like the cloud native approach to building the architecture. Like everyone always gets all hung up and they're like, I mean, the worst is when you're talking to the pure process people and they're like, we need to scale our agile software development. And you're like, you should just shoot me. Because your problem 99% of the time is not your process, your problem is your architecture. And that's like what's constraining your scale for both your humans and for your application. And if you internalize this notion of architecture and it's like self-aware of its own health, then your operational responsibilities get much, much easier. Because you're like, oh, look. Oh, the other idea, which I should have explicitly put in the slides I meant to when I was talking to myself about this talk, is in the world that we live in, that is at scale, if you want to work at scale, then you're going to work in a condition of continuous partial failure. There's no thing that's like 100%, right? Like what you need to think about when you look at your system is not like binary, is it on or is it off? It's like it has 95% hit points, right? It could still take half a blast from a rocket launcher, and then we just need to get some health. It'll be fine, right? Where it's like, oh, it's a 30%, I better be awake and like fixing it, right? Who actually carries a pager in this room? Not very many people. I mean, you're on call that someone will wake, you have to wake up and like make something work. Who has pager traumatic stress disorder?
Never again.
Yeah, it's a thing, right? It impacts you. So this guy, who knows who Jeff Hodges is? He used to work at Twitter. He just left a little while ago. He wrote an essay that everyone should read. So you should all read the Borg paper, and you should all read Distributed Systems for Youngbloods from Jeff Hodges. It's kind of an essay that walks through a bunch of the ideas about doing these kind of distributed systems, these notions of partial failure, queuing, back pressure, like all the things that you kind of need to know. Who thinks about back pressure? Who knows what back pressure means? So basically, I put some of this stuff here as like just like a grab bag of stuff, right? So back pressure is basically the idea that you should never have an unbounded queue. Unbounded queues are the White Walkers of distributed systems, and that when you get to the point where your queues are hitting their bounds, then like you should have some upstream way that you push back, and the system will like slow down, right? So like you have controls for the. You got that? Yeah, back pressure. So shock absorbers. So this is tribal signaling, right? When we have the right language, then we can have semantically dense conversations about the concepts, right? So in all of our little tribal cultures as companies, we tend to develop jargon that means stuff there. But one of the nice things, and this is what I consider one of the, like I didn't really say DevOps in this talk too much, but in 2015, and this was also true in 2009, 2010, up till now, we live in a world where we are all connected, and we are a community of practice, and we can share all these ideas, right? Like there is in a room full of people who are building these kind of systems, like we'll be much more effective at our work if we all can have a semantically rich conversation about things like back pressure, queuing, all these words and more that are on these slides, right? If you don't know what circuit breakers are, if you don't know what dark launching is, if you don't know what feature flags are, if you don't know what distributed tracing are, then these are opportunities, right, to educate yourself, to like understand what it means to have these capabilities. And it doesn't mean you have to go and do that, because we all have contexts, right? And maybe you're driving in the Derby, demolition derby, and maybe you don't need to have a Formula One car today. Or maybe you do, but you should at least know what you're building and what you're driving. So this is the thing that I think everyone should take away whenever you see anyone, present anything, not just me, that what you're trying to extract from that is a principle, not a technique. I think if you fixate on the technique, you lose like half of the opportunity. Like you want to frame things in mental models that are driven by principles that allow you to understand how to apply those things. And if you go into places, and the way I frame it in other talks and other work I've done is this notion of learning, the capabilities of an organization to learn. If an organization is able to internalize principles, then the practices and the tools will just emerge. They'll build their own, they'll either find their own tools or they'll build them. Where if you give someone the best possible tools and they don't have any connection to the principles, you can even tell them the practices. You can walk through the practices with them. And they're not going to be able to do the right thing until they internalize the principles. You can mimic, right? So who's ever heard the innovators, imitators, idiots cycle from Warren Buffett? I think all these buzzwords, they drive in this cycle, right? So you have innovators, imitators, the other word, not to be pejorative. So if you want to be the imitators, you can probably focus on the practices, right? If you want to be an innovator, you got to understand principles. And if you want to be that last category, focus on the tools. Why is better than what? Bigger, greater. Please quit building installers. I really hate it when people use their configuration management tools to build installers. Quit building these. Quit doing this. I didn't put enough fire in this talk. How many people built stuff before that they're like, wow, I know when this one thing fails. That one little thing, it's all resting on that one thing. And you know it's going to fail. Someday that will come. Hopefully I already got my resume out the door. So just to kind of bring it home, and then there's a couple minutes for questions maybe. What I would encourage everyone to do is really, and this is, Basho, quote, do not seek to follow in the footsteps of the wise. Seek what they sought. The problems that we're dealing with are not technical, and they're not people. It's a socio-technical problem. And I think it's interesting to watch. There's this pendulum in kind of the DevOps narrative where like you go someplace and they're like, oh man, people are talking too much about all this like soft human stuff. And then like you go to the next place and they're like, oh man, it's too much about tools. And like you really have to solve all of them together or you didn't solve anything. And I fundamentally believe this, and I try to live this way. If you've ever interacted with me, in IRC or email. Granted, I have a full-time job and 3 kids and a wife that has an 8-hour work week, but I definitely try to help people, right? And like there's a community of practice, and I know in my own career and my own journey that I would not be able to accomplish some of the things that I have accomplished without this deep network of people who know a bunch of things, right? And so I try to pay that forward. I know that if I have a problem with something, that like the person that wrote the thing will probably respond to my email or my IRC or now the Slack thing that the kids use or whatever. And so being able to connect to that community is like such a powerful thing, and I would encourage all of the people in this room to connect themselves to each other and to that global community. And that this thing, operability is really an intersection of capability and usability. And if you have something that's super capable, but no one can use it, then it's LXC, right? And then if something is usable, but like you can't figure out how to turn your heat down, then it's not very capable. So finally, don't seek DevOps, continuous delivery, agile, containers, microservices. Seek awesome. Thank you. I'm not here to answer questions. I'm here to have conversations. Yes, sir.
So you said you've been saying most of this since like 2007.
Some of it, certainly.
Some of it.
Yeah.
But you're not the only one,
Absolutely.
This DevOps thing has been going on for a long time. how do we deal with the guys that aren't already doing it? The guys that are out there creating DevOps teams and doing agile, and like you said, trying to scale agile.
I mean, in some sense, Agile went through the same cycle right before DevOps did. Going back to 2001, Agile Manifesto. There's already
Bit of an overlap.
yeah, but the Agile Manifesto signed in 2001. You don't really see DevOps as a word in usage till 2009. So there's a phase there. And I when I first started talking about this stuff, I actually called it Agile infrastructure, and I saw this as just an extension of applying some of those same principles to infrastructure. And what I came to realize is like what I want to be is someone who creates value and creates products, and what I don't want to be is a coach, right? And I think that there's an opportunity to like help people, and then there's people that I think are kind of I don't want to say parasitic, but I'm going to say parasitic. That really don't add a lot of value, that are like monetizing coaching in those ecosystems. And what I came to try to embody in my own work is like just be so good at what you do that like it's the obvious way to do it. And like I don't want to argue with people. Like I don't want to explain to you why ITIL is terrible. Like I just want to put you out of business, right?
That's fair.
I mean, like I didn't really answer your question. Like I don't like you can't help people that don't want to be helped, basically.
What about the ones that are on the path but maybe have got slightly the wrong idea? Is there no hope for them?
No, you get them to the meetups, you get them to the operability conferences, like you have those conversations, and then you just try to lead by being an example. And like it's not necessarily up to me to say like you shouldn't have a DevOps team, right? Like what you should try to do is be awesome. Like I don't care if you have a DevOps team. If that helps you get better at what you're doing, like I don't care what that team is called. Like granted, you're not going to solve your problem of a silo here and a silo here by putting a silo in the middle, right? But like if it helped you to have some discussions and facilitate flow, and you're starting to have ambient communication and information radiators, and people are monitoring their things and they're getting better deployments, like I'm not going to go tell them that they're doing it wrong, because they're getting better, right? Like we're all at a different phase of that journey, and I don't want to be the one to be like, oh, everything. Like I want them to get better. I mean, I could probably like just be a DevOps consultant forever, but like I don't want to do that. Like I tried to do that for 2 seconds, and I was like, wow, this sucks. Because like you literally go, like I got paid. Someone's like, give us the DevOps. I'm like, I'll try it, and then you go there, and they're like, all right. After you like analyze everything they're doing and like made some very specific recommendations about how to do it, they're like, how can you give us DevOps but we don't have to change anything? And you're just like, I'd rather go build stuff, right? Like I don't want to be a thought leader. I want to build like businesses. I want to like make money and hang out with my kids. Like that's my goal.
Thank you again.
Good, thank you. Thanks for having me.